The cosine rule. Well, the cosine rule, like the sine rule, helps us to work out missing lengths and missing angles in non-right-angled triangles. And the cosine rule is all concerned with something called a trapped angle. Now this means you have an angle between two sides. I should say two known sides. All angles are between two sides, between two known sides. So a triangle like this, I'd use cosine rule if I have this angle here and this side and this side. I'll use cosine rule, whereas if I had a triangle like this, where I had angle, side, I would use sine rule because I have pairs. In the cosine rule, I do not have a pair and I only have one angle. So the first thing you need to do is make sure you know which rule to use for which triangle. If it's got a trapped angle, then it is cosine rule. Now the cosine rule helps us find missing sides and angles. And just like with the sine rule, where I would say I had a over sine A equals b over sine B, and then flip it to find the angle, I rearrange the cosine rule in a similar way in order to find the angle. Now the first thing we're going to do is actually derive where the cosine rule comes from. This is, whether you sort of like the derivations or not, it is important to be able to do them because there have been questions where you are asked to derive either the cosine rule or some other formula in a question, and so it's important that you can do that. So what I'm going to just start with is, here's our triangle, and I'm going to label the corners. So A, let's go anti-clockwise, B and C. Okay, so the angle here is angle A, the angle here is angle C, and the angle here is angle B. I'm only going to label on the A angle though, because that's the only one that at the moment I'm interested in. Our sides, just like with sine rule, are sort of opposite to it. So opposite side to the angle A is little a, little b, and this side is little c. Okay, so what I'm going to do in order to derive this formula is I'm going to draw a straight line down the middle of my triangle. Now this line is at right angles to the base, and so we could call it the height. So I'm going to label it h. That's the height of my triangle. Now, what you might be thinking is, well, it's going to be half of c times h, that's the area of my triangle. But you're not going to be given h in questions. This is just for derivation purposes. Now what I'm going to do is I'm going to split up this bottom length, and I'm going to say that I'm going to call this bit here x, which is going to therefore make this side c minus x. Hopefully that makes sense. This whole length is c, so between here and b is c minus x. Okay. The next thing I'm going to do is I'm going to think about this triangle here, this triangle on the left. And I'm going to write, using Pythagoras, that I know that x squared plus h squared must equal b squared. Okay, that's my first equation that I'm going to write. That's going to be useful. The next thing I'm going to do is the same for the right-hand triangle. Okay, so we've got a rule for we've got an expression for the left-hand triangle and one for the right-hand triangle. So number 2 goes over here. So for this one, I'm going to say, okay, well, h squared plus c minus x squared equals a squared. Okay, so I've almost got a bit of a simultaneous equation. And we know when we're working out cosine rule questions or sine rule questions, we don't use the h. So we want to eliminate h to start with. So our first step is going to be eliminating the h term. So to do this, I'm going to do equation 1 minus equation 2. So 1 minus 2 this is going to give me x squared minus c minus x all squared. And on the right hand side, b squared minus a squared. Okay, right, I'm going to keep going with this. I'm going to simplify it a little bit. So I'm going to expand out this term here. The other thing to think about is we don't want h. We also don't really want x. So we're going to eliminate x as well. So to do this, if I expand this double bracket, I have c squared minus 2cx plus x squared. If I expand this bracket out, I have x squared minus c squared plus 2cx minus x squared equals b squared minus a squared. I can then cancel the x squareds and I end up with 2cx subtract c squared equals b squared minus a squared. Now I'm going to rearrange this again. I'm going to make it a squared to start with. So we have a squared equals b squared plus c squared minus 2cx. Now the next thing we want to do is we want to actually define what x is. So up here, if we look at x, we have b and we have h and x. The angle is a. So what we want to do is we want to define this length x without using h. So we don't want to use h. We want to find out what this is. So if we think about it, it's going to be cosine because it's adjacent, hypotenuse, and the angle. And so I'm going to write that x equals b cos a. Okay, now if I substitute back in b cos a in place of x down here, I have a squared equals b squared plus c squared minus 2cb cos a. Now this is the cosine rule. However, this CB bit, I don't really know why, but we generally don't write it as CB. Instead, we do something which seems counterintuitive, and we put two C's next to each other. All we do is we swap over the B and C, so we have A squared equals B squared plus C squared minus 2BC cos A. That is the cosine rule. Some of you will know it already, but that is the derivation for it, and you need to know it. So we have the cosine rule. And after a very short amount of time, this will be ingrained into your head, and you will not forget it. This helps us find a missing side. So we use this for a missing side. Okay, so if you have the angle, so it might be something like this, where you have this angle, say this angle is 49 degrees, this is A, you have B, it might be 7, C is 8. In this situation, you'd use this type because you have a missing side, but you have two sides and the angle. So what if I want to find the angle, but I have all the other sides? So I have 7 centimeters, 8 centimeters, this one's 9 centimeters. I don't have the angle. Now what I could do is I could use this formula here, put all the stuff in and rearrange it, or I could be a bit cleverer and I could rearrange it first so that my answer gets spat out straight away. So to rearrange this, we start with it in this form. I'm going to add 2bc cos a, and at the same time I'm going to subtract a squared. So we're going to end up with 2bc cos a equals b squared plus c squared minus a squared. Now what I'm going to do is divide by 2bc. So I end up with cos A equals b squared plus c squared minus a squared all over 2bc. So this I use for missing angles. Now, in both of them, both formula have one extra step. So the extra step in both these formulas is for sides, your final step, or your extra step, is square rooting. And for a missing angle, your final step is to find the inverse cos. So you do cos to the minus 1 of the answer. So in both cases, they don't spit out an answer straight away. You have to either, in the case of sides, square root, and for angles, do cos to the minus 1 or the inverse cos. Okay? But I do highly recommend that you use this form for angles and this form for sides. The more rearranging you have to do, the more chance there is for you to make an error. The other thing I will say is you can also rearrange this by subtracting b squared and c squared. I just wouldn't. You end up with lots of minuses, which you can easily forget. There's only one negative, and that's the a squared. Okay, so if we apply this to a few questions, let's just make sure. Okay, let's apply this to a couple of questions. I'm going to draw a few triangles out, and we're going to work through the method to make sure we are happy with it. So here are 3 triangles. Okay, so for the first one, this angle here is 55 degrees. I have 5 centimeters and I have 6 centimeters, and we want to find this side A. In this question here, I have 41 degrees, 8.2 meters, 7 meters, and I want to find this missing side here. This final question, I have 49 degrees, I have 2.4 centimeters, 3.7 centimeters, and I want to find this side. Okay, so pause the video now, have a go using that cosine rule, and then I'll go through the answers. Okay, so for the first one, a squared equals b squared plus c squared minus 2bc cos a. Just fill in everything you know. You know this is angle A. You know that these sides are B and C. By the way, it doesn't actually matter which way around you use these. It doesn't matter at all. If you look at the formula, we could swap these over. That wouldn't matter. And we could swap these over. That wouldn't matter. Okay, so don't get too hung up about which one's B and which one's C. Okay, unless of course it is the missing angle, in which case, you know, be careful. So for this one, a squared equals 5 squared plus 6 squared minus 2 times 5 times 6 cos of 55 degrees. Make sure your calculator is in degrees. Once you fill this in, you can just put it in. So 5 squared plus 6 squared minus 2 times 5 times 6 times cos of 55. This gives me 26.585 . So that's my answer. Oh wait, no it's not. I haven't square rooted it. Okay, so make sure that you square root it. It should be obvious if you haven't square rooted it. 26 is clearly not the right answer. It's far too long. So once you square rooted it, you get the answer 5, or to one decimal place, you get the answer 5.2 centimeters. Obviously discount the negative answer you get because it is a length. Okay, moving on, this one up here. Okay, again, a squared equals, this is our A angle, B and C are the two either side, they're the ones trapping the angle. So we do 8.2 squared plus 7 squared minus 2 times 8.2 times by 7 cos of 41. Sorry, that's got so small. A squared, therefore, equals 29.59 square root it, that final step, and we get 5.4 meters to 1 decimal place. Okay, final one down here. Again, this is A, B and C either side, they're trapping that angle. 2.4 squared plus 3.7 squared minus 2 times 2.4 times 3.7 cos 49. So this gives me 7.79, which I'm going to round to 7.8. Look at the unit, centimeters. Okay, so that is how you find the missing side, and you can practice that to your heart's content. Okay, so finding a missing angle. Let's draw, we'll just do 2 triangles here. Okay, so for the first one, we have a missing angle here, which I'm going to call X. We have this side here, which is 9 centimeters. This side is 11 centimeters. And this side here is 12.5 centimeters. Okay, so we're going to use that formula we worked out previously of cos A equals B squared plus C squared minus A squared all over 2BC. So B squared, remember, this is our A, this is our little a, this is our little b, this is our c. Obviously these two are interchangeable. So we go 9 squared plus 11 squared minus 12.5 squared all over 2 times 9 times 11. Again, it's just a case of putting it into your calculator and being really, really careful. So cos A gives me an answer of 0.231. If I do cos to the minus 1 of that answer, I get my angle, which is 76.6 degrees. Okay. Okay, so question 2 up here. Let's go for this angle here. We will call, this is big A. Okay, so for this question we have A, little a, B and C. I'm going to say this is my, sorry, I should say, I do this sometimes, it's x equals 76.6, isn't it? Apologies. Anyway, let's have a here. Let's call this one y, and let's say we have 1.2 meters. We have this one is going to be let's go for 3.5 meters, and a goes somewhere in between. Let's say it's 2.7 meters. Okay, so start again with our formula. Cos A equals b squared plus c squared minus a squared all over 2bc. So we have 1.2 squared plus 3.5 squared minus 2.7 squared all over 2 times 1.2 times 3.5. Go into your calculator. I get cos A equals 0.76 ... Therefore, cos to the minus 1 of that answer gives me 40.4 degrees. Okay, so that's how you find the angle. Now, beyond this, with cosine rule, you have to apply these methods to bearings questions and combine it with the sine rule. Now, when I say combine with the sine rule, what I mean is there may be a question where in the first part you have to find the angle, second part you have to find the side, and you may need to use sine rule and cosine rule at the same time in order to do that. So here's our cosine graph. And what you notice is if we have a triangle, remember these triangles, the angle can go from 0 up to being really, really, really obtuse. Okay, so for the triangles we're dealing with, the zone we're actually looking at is between 0 and 180 degrees in here. Okay, we could have an angle of 120 here, we could have it bigger, and we could have a tiny angle we're dealing with. So one thing that's important to notice is when you do, for example, when you do cos A and you find an answer, that answer could be negative. Okay, that answer could be negative. And if it is negative, it doesn't mean you've got it wrong. Okay, if it's negative, all that means is you're dealing with an angle which is obtuse. Okay, so if your answer comes out here, for example, of minus 0.2, and you track along, it will come out somewhere here. Okay, maybe somewhere around about 100 degrees. Now that's not a wrong answer, that's fine. So if you get a negative, do not panic, just think about the graph. We're dealing with 0 to 180 in terms of degrees. So we're going to go positive and then negative. Okay, negative will be obtuse. 0 to 90 will be acute. But there isn't a problem like the sine rule. There is no ambiguous case with cosine. Okay, go and practice and have fun.